everyone, Radical Tutor here explaining. In this video, we are going to look at what we call as partial fractions. Now, what are these partial fractions? Partial fractions are simply a way of breaking down a complex rational function into a simpler functions or fractions. Alright, now, what I mean here is that if you have a complex rational function, you'll be given a bigger function or fraction, and then now you'll be told to break down that complex function into smaller ones. Then you are doing what we call as decomposing into partial. So what happens is that you'll be given a very big function, and then you'll be told to break down this function into what? Into smaller ones. So once you do that, meaning that you are doing what we call as decomposing this big function into partial what? Partial fractions. So this is what we mean by partial fraction. So in other words, we even use this in a real life language, where you say maybe if I'm owing you 100 kwacha, and then I tell you that I will be paying you in partials. All right, that means that if I'm paying you in partials, that means maybe I'll be giving you 100 kwacha, 100 kwacha, 100 kwacha in smaller amounts, not until the 100 kwacha is fully paid. So that's what we mean by partial. Partial meaning that we are dividing a complex something into smaller items. So that's what we mean by partial. So even in mathematics, we also have what we call as partial fractions, where you are given a very big fraction, and then you are told to divide or break down that bigger function into smaller ones. So that's what we call as partial fractions. All right, now we have what we call as types of partial fractions. So we have what we call as types of partial fractions. So types of partial fractions. All right, types of partial fractions. Now here we have about 5 types of partial fractions, and these are: number one, we have what we call as linear. So we have number one, we have what we call as linear factor. Number two, we have what we call as repeated linear factor. Number three, we have what we call as quadratic factor. Okay, quadratic factor. Number three, we have what we call as repeated quadratic factor. Number five, we have what we call as improper fraction. So we have what we call as improper fractions. All right, so these are the types of partial fractions that we have. So what are we supposed to do then? What we're supposed to do is simply to go into them one by one and see what we really mean on each of them. All right, so we're going to start by looking at what linear factors are. Linear factor partial fractions. So in other words, remember we are saying that under this topic, you'll be given a very big function and you'll be told to decompose it into smaller functions. So that's, or fractions rather. So you are given a very big fraction and you are told to divide this fraction into smaller ones like that. So this is what we're doing. So now in this case, we are going to look at what we call as partial fraction, where you are given linear factor. So that's what we're going to look at. All right, so we are starting with a linear factor here. A linear factor. Now, what is this linear factor? So a linear factor is a type of fraction where down the denominator you are given linear equations. So this is a type of fraction where in the denominator you are given linear equations. For instance, examples of linear fractions are those that can be written like this. Let's say we have 2x squared plus 4 over, let's say we have, here we have, okay, let me not use this, let me use this one. All right, so we have 2x plus 4 over, you are given x plus 1, down here you are given x plus 1, and you are given x plus 2. So these are what we call as linear factor, because when you look at the denominator here, you have this x, which is only the highest power of x here is a 1, and also the highest power of x here is a 1, meaning that these are called linear factors. Okay, another example of a linear factor is, so if we number one, number two, another example of linear factor is that if you have a 7 over x minus 1 and x plus 1, these are also linear factors because we are looking at the highest power of x here is what? 1. So if something has, if the variable x has the highest power of 1, meaning that those are said to be linear equations or linear expressions. So meaning that if we have these linear expressions down the denominator, then just know that what we are dealing with is a linear factor, the partial fraction. Okay, we can also, you can still have this, maybe we can have also 3x power 3 plus 4x squared plus 5x over you are given maybe you are given here, okay, plus 5 there, then you are given x plus 5 and x minus 4. So this is still a linear factor, but to make it just simple, I can remove this. I can remove this, just I make it simple like that. All right, so that is it. So let me even just remove this so that I just make it simple. All right, so this is what we call as a, let me do that, 7x plus 5 over these linear factors. So this is how you know that this is a linear factor partial fraction. Now let's look at how to decompose these linear factors into partial fraction. So how do we decompose these linear factors into partial fraction? So what we're supposed to do is we are going to have an example and see how to decompose or resolve. So they say decompose or resolve. Whenever you hear the word decompose or resolve this into partial fraction, meaning that we are reducing it from its complex fraction to simpler ones. So let's have an example and see. So an example that we're going to have is that they say decompose. So we're going to say decompose the following into partial. All right, so we're saying that decompose decompose the following into partial fractions. So decompose the following into partial fractions. Now for you to decompose into partial fractions, what we're supposed to do is we have our first question here, which is given as 1 no, let me use this one, which is 3x over x minus 2 and x plus 5. So we are decomposing this into partial fraction. Now for you to decompose that into partial fraction, what you're supposed to do is very simple. You just need to get this same question which is given. So we are now, in other words, we are given a complex fraction. Now we are making it or decomposing into partial fraction, meaning that we are dividing it into smaller what functions, or I mean fractions. So that is what we mean by decomposing it into partial fractions. So for you to decompose into partial fraction, and if it is linear, because we are given here the highest power of x is 1, there also it is 1, so you start by getting the whole question there. So the whole question is 3x over x minus 2 and x plus 5. Then you close. So from there, for you to decompose, what you need to do is you say a over the first factor, which is x minus 2, plus b over the second factor, which is x minus 5. So if that is the case, then you just need to get the values of a and b. So in other words, we have decomposed this into these small functions, this and that. So always you say, if you have two factors, you just say a over this and then b over this. That is only if it is what? It is a linear factor. So you just do that and that. If you had three factors here, maybe x minus 6, would have also added there to say plus c over x minus 6. Okay, but since we only have two, we are saying a over this, b over that. Then that's when now we can decompose. So to decompose, what you need to do is to multiply what you've the assumption that you've made here throughout with the factors that are down here. So you multiply this throughout by this one here. So that is we are multiplying by x minus 2 and x plus 2. So x minus 2 and x plus 5, like that. So we are multiplying throughout this equation. So when multiplying, you multiply this to this, you multiply this to that, you also multiply that to that. Okay, so by doing so, we are going to say this times that, you are going to have 3x will remain because this. All right, so why is 3x remaining? Because these two are going to all right, so I'm saying that this one and these two cancel. You are only going to remain with a 3x, and then when you multiply, so we're going to say this is equal to, so this is equal to, when you multiply this and this, multiplying this and this, you are going to find out that the x minus 2 and the x minus 2 go, you remain with a times x plus 5. So you're going to remain with a times x plus 5, and then plus b. When you multiply this and this, you're going to find that the x minus 5 and the x plus oh, this is supposed to be a plus here. All right, so this is supposed to be a plus here, like that. Okay, this is supposed to be a plus like that, so that when you multiply this and this, you're going to find that the x plus 5 and the x plus 5 will go, and then you remain with b times x minus 2. So you're going to remain with b times x minus 2 like that. All right, so from there now, that's when you can get the values of a and b. How can you get the values of a and b? You start by, if you want to get the value of a here, if you want to get the value of a, of a, find ways on how you can cancel the part for b. So how can you cancel the part for b? You can start by letting x to be 2, so that when you put a 2 here, you are going to find that you say 2 minus 2, 0, meaning that the part for b will go. So that's what you're going to do. So you start by saying let x to be equal to 2, so that we cancel the part for b. So if we are to do that, then we are going to have 3 times 2 is equal to a times, where there is x here, we are putting a 2, so we put a 2 plus 5 plus b open 2 minus 2, and therefore this will go to 0. Then we shall have 6 is equal to a times 2 plus 5, that is going to give us a 7, like that. Okay, so for you to get the value of a, you say over 7 over 7. That means 7 and 7 will go, and the value of a will be 6 over 7, like that. Now, that is how you get the value of a. Again, for you to get the value of b, meaning that you should find ways on how you can cancel the part for a. So for you to cancel the part for a, meaning that you should find a number that you put on x here, so that when you put it there, it gives you a 0, you remain with the part for b. That's what you do. So by doing so, you are going to say let x to be equal to -5. So if you let x to be -5 here, you are going to find that the x will go. The part for a will go, you remain with the part for b. So by doing so, you are going to replace it in this same equation here. So replacing it there, which is 3x is equal to a open x plus 5 plus b open x minus 2. So we are putting -5 whenever there is x, which is 3 times -5 is equal to a open -5 plus 5 plus b open -5 minus 2. So by doing so, we shall have 3 times -5 is -15 is equal to, this part will go to 0 and will remain with b times -5 minus 2 is -7. So we have -7b. -7b, have multiplied -5 minus 2 times b, which is -7b. And then for you to get the value of b, you divide by -7, you divide by -7, and therefore this and that will go. Then our b will be equal to 15 over 7, because the negative and the negative will go. So we're going to have 15 over 7, that is the value of b. Now, from there, after you get the values of a and b, remember we had to say that when you decompose this into partial fraction, you get this and that. So what you just need to do is to come back and replace back what you found on a and what you found on b. So you come and say, therefore, decomposing 3x, the question was 3x over x minus 2 and x plus 5 is equal to, remember we had a over x minus 2 plus b over x minus 5. So what you do is just replace on a, you put the value that you found, and on b, put the value that you found, meaning that you are done. So by doing so, you have the 3x over x minus 2 and x plus 5, which is equal to, what is the value of a? The value of a is 6 over 7. So you put 6 over 7, 6 over 7 on a. Okay, so 6 over 7 on a, then over x minus 2, then plus our b is 15 over 7 over what? Over x plus 5. I don't know why I'm writing the minus here, so we're supposed to put a 5 here. There's a plus 5, not minus 5. All right, so we need to put a plus 5 there. All right, so we are putting a plus 5. Now this can also be written as, this is equal to, it can also be written as 6 over the 7 can be down, and then x minus 2, then plus 15 over the 7 also can be down, and then x plus 5. So meaning that when you do this, it means you've written this into partial fraction. So this is, you've written this complex fraction into some simpler functions. So you've written this into the simpler fractions, which is this and that. So that is what we mean when we say decompose into partial fractions. All right, so from there, what I want you to do is, I want you to try this as your task. So I want you to do this as your task. So task on the first one is, I want you to decompose or resolve these into partial fractions. So the first one that I want you to do is, I want you to do 7x minus 23 over x minus 6 and the 3x plus 1. So this is what I want you to do as the first task for the linear factor. So we've done the linear factor. Now from here we go to what we call as repeated linear factor. So we are going to repeated linear factor. So we go to repeated linear factor. Okay, linear factor. So when we say repeated linear factor, what we mean is that you have linear factors, yes, down the denominator, but now for instance, I can give you examples like 2x plus 1 over x minus 1 and then x plus 2. You've seen the way this expression is written. So this, by definition, it is a linear factor because we have this highest power 1, highest power there is 1. We have two linear factors. But in the case where one of these has got a square, let's say we put a square here or maybe another square here, that means that these are repeated linear factors because what is inside is a linear factor, but it is repeating. When I say x minus 1 squared, meaning that this number is this expression inside, it's repeating itself. Okay, that means it can be written as x minus 1 and x minus 1 like that. So meaning that it is repeating. So no wonder they are called the repeated linear factor. So the linear factor is repeating. All right, another example that we can give here is, we can, so this is number 1. Number 2, we can say we have 7x minus 1 over, we have x plus 5 squared, like that. This is also a repeated linear factor because what is down here is a linear, but it is having a square, meaning that this linear factor is repeating itself. Number 3, we can also give an example of a repeated linear factor, as maybe we can have a 7 over x times x plus 4 squared. This is also repeated because we have this one, a linear, which is repeating itself. So these are called repeated linear factor. All right, so now how then do we decompose these repeated linear factors into partial fraction? So to decompose this into partial fraction, we are going to have an example and see how we can solve them. So example, you are going to say decompose the following into partial. So decompose the following into partial fractions. So to decompose them into partial fractions, what you simply need to do is, we are going to look at some repeated linear factors. So number A, we are going to have the first one that we are going to have here is 1 over x minus 2 squared and x plus 1. That's the first one. The second one is, we are going to have so let me also write another one here. So another one that we're going to have is 7x minus 4 over x plus 1 and x minus 2 squared. So these two are repeated linear factors. Okay, so now how do we decompose repeated linear factors where maybe a linear factor is repeating itself? When we say it is repeated meaning that it is having power 2. That's what we mean by repeated linear factor. All right, so instead of you solving the linear factor, you are now solving the repeated linear factor. Now, how do we decompose? So what you're going to do is, I'm only going to solve the first question, and then this one will be your task there. All right, so you try it there. So let's try. So we are going to say solutions. So let's say solutions. So solutions here, solutions, we have the question number 1, which is we are decomposing 1 over x minus 2 squared times x plus 1. So whenever you are decomposing this into partial fraction, whenever you are decomposing a linear factor into partial fraction, what you are supposed to do is you say this is a over the first factor. Now since this is repeating, okay, since this is repeating, what you are going to do is this. Okay, what we're going to do is this. But before even we do this, let me add another example so that you can easily understand here. So we can say we're adding another example. So another example is C, where I want you to decompose a 7 over x minus 1 squared. That is also repeated because what is given down is repeating itself, so it can be called repeated linear factor. So we can even put 7x over 1 minus x minus 1 squared. It is also a repeated factor. So allow me to call this as A, this as B, and that as C. So allow me to change them like that. So now from here we are going to start with question A. So question A, solutions, we are going to say that we are decomposing the 7x over x minus 1 squared into partial. How do we decompose a repeated linear factor into partial? So to decompose repeated linear factor into partial, what you simply need to do here is to write this assumption here. So the assumption will be A over the first factor. Now when you're decomposing repeated linear factors, you start by saying A over what is just inside here. So you say A over x minus 1, then plus B over the whole repeated factor, which is x minus 1 squared, which is going to be x minus 1 squared. So we have x minus 1 squared. So this is what you do when you are decomposing repeated linear factor. So this is the first step that you do. So you say A over what is only inside plus B over everything given as a repeated. So this is what I've done, and then from there now you need to start by getting the value of A, and then you go to value of B. So how can we do that? The same procedure that we've used under linear factor is the same one that we are going to do under repeated factor. So by doing so, you are going to multiply this. So you multiply this throughout by x minus 1 and x minus 1 squared. But now look at this, sorry, what are we going to multiply with there? Sorry, not that, not this. Remember, I have said that you need to multiply throughout by the denominator, which is here. So the denominator is x minus 1 squared. So x minus 1 squared is what we are going to multiply here, which is x minus 1 squared. So from here, what you need to do is to multiply throughout. So you multiply this with that, and then you also multiply this with that, then you also multiply this with that. So that's what we're going to do. So by doing so, we are going to say if we multiply this and this, we are going to remain with only 7x is equal to, if you have to multiply this and that, remember this has x minus 1, here we only have x minus 1. So if you have to multiply this and that, you're going to find that one of the x minus 1 will cancel with one of the x minus 1. You only remain with x minus 1. So you're only going to remain with A times x minus 1, and then plus B open. You also multiply this and that. That means that if you are to do that, you are going to realize that this x minus 1 and x minus 1 will cancel. You remain with only a b there. So you are going only to remain with that b like that. So you are going to remain with the b. So that is the b that you are remaining with. Now here you need to get the values of a and b. Now to get the values of a and b, what you can simply do here is that you have two methods. You can start by cancelling the part for a by letting x to be 1, or so you can start by letting you can start by, this is x here. All right, so this is x here. So now you can start by getting the value of b by letting x to be 1, so that the part for a goes, and then you remain with b is equal to this side here. Or if you don't want to do that, what you can simply do is, so let's use the same one which we've already used on top. So we're going to say let x to be equal to 1, so that the part for a goes. So that means we have 7 times 1 is equal to a open 1 minus 1 plus b there. Then from there, this part for a will go because we are going to get a 0, and therefore our b is going to be a 7. So after I've gotten the value of b as a 7, now we need to also cancel the part for a so that you get the value of b. Now to do that, for you to cancel the part for a, for you to cancel the part for b so that you get the value of a, it will be very hard because b here has no factor, maybe like x minus 1 or x plus 2 or something. All right. So that means it will be very hard for you to cancel the part for b. So if you see that you are failing to cancel something under partial fractions, simply just let x to be 0. Okay, so you simply just let x to be 0. So we say let x to be equal to 0. So if x is 0, you are putting 0 throughout there, where you're going to have 7 times x is equal to a open x minus 1 plus b. So our x there is 0, and therefore we're going to have 7 times 0 is equal to 7 times 0 is equal to a open, you have, we put 0 here, which is 0 minus 1, then plus b there. All right, so now here, remember, don't forget that the value of b has been found already. Where is the value of b? The value of b is here. So you can simply just replace b with this value you've already gotten here, which is a 7. So by doing so, you are going to put a 7 here. Okay, so by putting a 7 there, now we'll say 7 times 0 is equal to 0 minus 1 here is a negative 1 times a is negative a, then plus 7 here. So you need to correct like term, you can bring the a this other side here so that you get its value. So that's just an equation. So you say a is equal to what? The 7, which is the other side there. All right, so this is how you get the value of a. So after getting the value of a, that means you need to replace it back in the assumption. So meaning that you go and replace a here, you also go and replace b there. So that means you are done with decomposing or resolving that into partial fractions. So just go, the value of b is what? You put it 7. The value of a also is what? Is 7. So you go and replace them there. So by doing so, you are going to say that therefore, so in other words, our final answer will be equal to our a, we are putting a 7 over x minus 1 plus our b, we are putting also a 7 over x minus 2 squared, like that. Okay, so that is what we are going to have. All right, so this is going to be our final answer if we are to resolve this into partial fraction. All right, now we are going to resolve also this into partial fraction so that you do that as your task. So when resolving this into partial fraction, we have 1 over x minus 2 squared and x plus 1. So number B, we have 1 over x minus 2 squared and the x plus 1. So what you need to start from here is that you need to start by making the assumption where you are creating the AB. So you have 1 over x minus 2 squared and the x plus 1, which is actually going to be equal to, you say a over the first factor. Since this is a repeated here, you say a over what is just inside, which is x minus 2. So you say a over x minus 2, and then you say plus b over whatever that is put now there, what is given to be a square. So that's what you do when it's repeated. So b over x minus 2 squared, and then plus, since we have another factor which is x plus 1, we need to include a c over that factor, so it will be a c over that factor which is x plus 1. And then from there, now we need to get the values of a, b, and c. So that's what we are supposed to do. So please, whenever you see that you have a repeated, you need to first say a over what is inside plus b over what is given, the whole lot of that which is given as a square or a repeated. Okay, then if you have an extra factor, please include another variable which is c over that same factor which is there. Then from there, that's when you can now decompose into partial. So by doing so, we are saying that you need to multiply this throughout by your factors which are down here, which are x minus 2 squared and x plus 1. So you're multiplying this throughout by x minus 2 squared and x plus 1. So if you do that, you're going to find that you multiply this and this, you also multiply this and that, you also multiply this and that, you also multiply that and that. So if you have to do that, then it becomes easier. So remember, what we're doing there is to just find the values of a, b, and c. So if you have to do that, you are simply going to multiply. When you multiply this and that, you only remain with 1 this side. So you only remain with a 1 is equal to, you multiply this and this. So you multiply this and that. You are going to find that the x minus 2 and 1 of the x minus 2 there will cancel. You are going to remain with a times x minus 2 and x plus 1. Then plus b, if you are to multiply this part and this part, you are going to find that the x minus 1 and the x minus 2 go, you remain with b times x plus 1 there. So you're going to remain with b times x plus 1. And then plus, when you multiply this part and that part, you're going to find that the x plus 1 and x plus 1 will go, you remain with c times x minus 2 squared. So you remain with a b times x minus 2 squared, like that. So by doing so, then you are going to get the values of a, b, and c. Sorry, this is a c here. You can change this. So this is a c here. Okay, this is a c. So now from here, we can get the values of a, b, and c. How can we get the values of a, b, and c? You start by cancelling the parts here. You can say, if let's say if I let so we can say if I let x to be equal to 2, that means the part for a and the part for c will go, because we are going to get zeros here, because here we put 2 minus 2, it's a 0, 2 minus 2, it's a 0. So these two will go and we are going to remain with the part for b, so we are going to get the value of b there. So let's do that. So we are going to say 1 is equal to, this part will go, this part will go, this part will go here. For c, we remain with the part for b only, which is going to be b times x plus 1. Okay, then now we put 2 here where there is x, which is going to be 1 is equal to b times 2 plus 1, which is going to give us 1 is equal to 2 times 2 plus 1 is 2 times b is 2b. Then for you to get the value of b, you say over 2, and then these two go. Therefore, the value of b is going to be 1 over 2. So that's what you're going to have there. All right. So after saying b is equal to 1 over 2, you now then go and replace also another number in these assumptions here, here, and there, so that you cancel the part for a or maybe b, so that you get the value of c. All right, so now you are going to realize that if we put -1 here on x, you are going to find that this part for a and the part for b will go, you remain with c. That's what we are going to do. So we are going to put -1, or let x to be -1, so that the part for a and the part for b goes, and then we get the value of c, because here it's not going to cancel. All right, so by doing so, we are going to say let x to be equal to -1. So if we are to do that, we have our equation which is here, which is a 1 is equal to a open x minus 2 x plus 1 plus b open x plus 1 plus c open x minus 2 squared. So we are letting x to be -1, so it will be 1 is equal to a open x, we are putting a -1 minus 2 times -1 plus 1 plus b open -1 plus 1, then plus c open -1 minus 2 squared. So you're going to realize that this part will go to 0, that part also go to 0, you remain with the part for c there. So we're going to have 1 is equal to -1 minus -2 is -3, -3 squared, we're going to get a 9. So we're going to get a 9c. So for you to get the value of c, you say over 9, say over 9. So this and that will go, and therefore our c is equal to 1 over 9. So that's the value of c. Now for you to get the value, which value is remaining? The value of a. So for you to get the value of a, you are going to realize that it's very hard for you to cancel the part for a. So if it's very hard for you to cancel the part for a, because you cannot let any number for you to cancel the part for a, if you, for you to get the value of a, it will be very hard for you to cancel the part for b and d and c, because these have different numbers inside there. So you cannot, if you let maybe x to be -1, you only cancel b and d, c will not cancel. So meaning that if you see that you are failing to cancel, always let x to be 0. All right, so you say let x to be equal to 0. So if it's 0, we get this equation. So we're getting this equation and replacing. Whenever there is x, we put a 0, and whenever there is b, remember we've already found that it's this, c also found that it's that. So our equation is 1 is equal to a open x minus 2 x plus 1 plus b open x plus 1 plus c x minus 2 squared. So by doing so, we are going to say that we are letting x to be 0. So we say 1 is equal to a open 0 minus 2 open 0 plus 1 plus the value of b, we've already found it to be 1 over 2. So we put 1 over 2 here, and x is 0 plus 1. Then plus c open x, we are putting 0 minus 2 squared. All right, so from there now we need to simplify the answer. So we say 1 is equal to 0 minus 2 is -2 here, -2 times 1 here, we get -2a. Okay, because we are also multiplying with the a here. Then from here we say plus, we have 0 plus 1 is a 1, 1 times half, we get half here, and then plus 0 minus 2 is -2, -2 squared is 4c, so we get 4c. Now after I've done that, you need to get the value, and I've forgotten, the value of c is already known as well. So the value of c is known to be what? It's here, 1 over 9, so you put 1 over 9. Okay, so meaning that here what you can simply do is, when you're replacing there, it says 0 minus 2 is a 2, then -2 squared is a 4. 4 times 1 over 9 is going to give us 4 over 9. Okay, so we shall have 1 minus 2a, 1 is equal to -2a, then we say plus 1 over 2 plus 4 over 9. So 1 over 2 plus 4 over 9, we are going to get a 17 over 18. So we get 17 over 18, and then now you need to solve this as an equation to get the value of a. So to get the value of a, we shall say the 2a can come the other side here. It is going to be a positive 2a is equal to, this side we have a 17 over 18 minus 1. The 1 will go the other side like that. Okay, so we shall have 2a is equal to 17 over 18 minus 1. Okay, so when you say 17 over 18 minus 1, you are going to get -1 over 18. So you get -1 over 18. Now for you to get the value of a, you divide by 2 here, you also divide by 2, or you can say divide by 2 like that, so that this and that will go, and the value of a is going to be -1 over 36. So you know the value of a, b, and c. What do? You come and replace them back in the assumption here like that. So you put the value of a, the value of b, and the value of c, meaning that you've decomposed this into partial fraction. So by doing so, we are going to say therefore our final answer, if we are to decompose, we are decomposing 1 over x squared minus x squared, 1 over x minus 2 squared plus times x plus 1. So we are decomposing 1 over x minus 2 squared open x plus 1. We are saying that this, our answer was a over x minus 2 plus b over x minus 2 squared, then plus c over x plus 1. So we've already found the values of a, b, and c, so we just replace them. So it's going to be equal to, what's our a? Our a is -1 over 36 times x minus 2. Then plus our b, we've gotten what? Our b, we've gotten 1 over 2. So it's going to be 1 over 2 times x minus 2. And then plus, what's the value of c? The value of c, we've gotten 1 over 9, which is going to be 1 over 9 times x plus 1. So that means you've decomposed or resolved this into partial fraction. So you've resolved this into partial fraction. All right, so that's how you decompose if it is a repeated linear factor. Okay, so by doing so now, let's proceed. So we are going to what we call as improper partial fractions. So we are going to what we call as the improper partial fractions. Now, when or maybe before we even go to improper partial fraction, let's go to what we call as quadratic partial fraction. So we're going to look at what we call as quadratic factor. So we look at what we call as a quadratic factor. All right. So when we say quadratic factor, meaning that down you are given a factor which is having the x, its highest power is 2. So we are going to say we have a good example that I can give you is that you are going to have maybe e.g. So e.g. you have number 1, you have 5x squared, or maybe let me just say 5x over x squared plus 2. So you are going to realize that what is given in the denominator has the x highest power is 2. Okay, you've seen here this x is having highest power of 2. And we say that if any equation has the highest power 2, meaning that it is a what? It is a quadratic. So no wonder we are calling this as quadratic what factor. The factor which is down has x to be its highest power as 2. That means it is qualifying to be a quadratic factor. So now we can resolve or decompose these quadratic factor fractions into partial or simpler or small functions that we call as partial fractions. All right, another example that I can put there is simply just maybe we can have number 2, which is maybe 7x plus 4 over 3x squared plus 5. So by doing so, that means that we can decompose this one and that one into partial. All right, so these are examples of partial fraction. Number 3, examples of quadratic factors. So number 3, we can have 7x minus 4 over x plus 1, and then I put x squared plus 5. So these are quadratic factors because you are given this one of these factors, the highest power is 2, meaning that it is a quadratic factor. Okay, so if you have this, let's now see how we can resolve them. So I'm going to start with the first one, which is 5x over x squared plus 2. So example, we are going to say decompose the following into partial. So decompose the following into partial fractions. So decompose into partial fractions. Now for you to decompose these into partial fractions, what we are simply need to do is, so I'm going to say number A, we are going to have the first one there, which is a 5x over x squared plus 2. So how can we decompose this into partial? So if you have a quadratic factor in the denominator, what you need to do is that you start by writing it to say 5x over x squared plus 2 is equal to, if you down you have a quadratic factor, what you do is you write on top as ax plus b. So if it's a quadratic factor, meaning that on top you're supposed to write this linear equation, which is ax plus b. Okay, then over that factor given, which is x squared plus 2, like that. So you are done there writing that assumption. After writing that assumption, what you're supposed to do then is simply to just multiply this throughout by what is here, just like we've been doing. So you multiply by x squared plus 2. So if you have to do that, you need to multiply this to that, also this to that. Then you'll be able to find the values of a and b there. So by doing so, if you have to multiply this to this, you are going to find that this and this will go, you remain with 5x on top there. So you are going to remain with a 5x, and then is equal to, you also multiply this and this, you are going to find that this and this also will go, and then you are going to remain with ax plus b. So you're going to remain with ax plus b. Now from here, after you've done that, what you're supposed to do here is to get the values of a and b. Now when getting the values of a and b, we use what we call as, mostly when you are dealing with quadratic factor and repeated quadratic factor, we use the method that we call as the method of undetermined coefficient. So you use the method of undetermined we use the method of an determined coefficient. We use the method of undetermined coefficients. So the method of undetermined coefficient is like this. You need to equate. You've seen the way we have this equation here. We want to get the values of a and b. So the way we have this equation, what you need to do is equate those that are like together. So the like terms, equate them together, and those that are unlike also together. So I'm going to equate this to this, and also equate this to here. We don't have this, so we equate it to 0. So what I'm saying is that we're using the method of undetermined coefficient and it is used in this order, where you just say 5x is equal to ax, and then that is equation 1. Equation 2 will be 0 is equal to b, because here we don't have a number which is a constant this side. So we just say 0 is equal to b, which is equation 2. So if b, meaning that in this case our b is already 0, then just get the value of a on top there by saying 5x is equal to what? Ax. So divide throughout by x, divide by x, so that your a is equal to 5. Okay, so that's what we call as undetermined what? Coefficient. It's just the matter of equating the likes together and the unlike together, then you'll be able to get the values of the unknown variables. So after getting the values of a to be 5 and the value of b to be 0, then you just go and replace them in the what? In the assumption that you made there. So you say, therefore, 5x over x squared plus 2 is equal to, remember we had ax plus b over x squared plus 2. So what we simply need to do here is we have 5x over x squared plus 2 is equal to x, we are putting a 5, so we put a 5 there, and then, a we are putting a 5, not x, so we have 5x, and then plus b we are putting a 0 over x squared plus 2. So once you do that, meaning that you've resolved in two partial fraction. Okay, so this would mean 5x over x squared plus 2 is equal to, if you want, you can eliminate the 0 because it is nothing. So you have 5x over x squared plus 2 like that. So this is what you're going to have when you are to resolve this in two partial fraction. All right, so from there we go to solve these ones. We call them as what? Quadratic factors. So we need to go to another example. So what I'm going to do is I'm going to solve this one here, 7x minus 4 over x plus 1, and then we have x squared plus 5. That's what we're going to solve. Okay, so we're saying that's our question number 2. So question number 2, we are saying that we are decomposing 7x minus 4 over x plus 1 and x squared plus 5. X plus 1 and x squared plus 5, like that. Okay, so here what we're supposed to do is simply to start by writing the assumption. So writing the assumption is, what you do is, for you to write the assumption of this, what you're supposed to do is you say 7x minus 4 over x plus 1 and x squared plus 5 is equal to, you have a over x plus 1 and plus b. So now look at this. I'm saying that the first one is just a linear factor, so it will be a over just that linear factor. Then the second one is a quadratic factor. So if you are dealing with this quadratic factor, you say bx plus c, because you need to write it as a linear over this. So you say bx plus c, so you say plus bx plus c over x squared plus 5, like that. Okay, so now after you've done that, what you simply need to do is to find the values of a, b, and c. So for you to get the values of a, b, and c, what you simply need to do is to multiply throughout, just like we've been doing. So you need to multiply throughout by the denominator here. So you multiply throughout by the x plus 1 and the x squared plus 5. So if you are to do that, you're going to multiply this with that, then this with that. So if you are to do that, then you are going to have, so if you are to do that, you multiply this with that, they will go, you remain with the 7x minus 4 on top. So you're going to remain with the 7x x minus 4 on top is equal to, we also multiply this with that. You are going to find that the x plus 1 and the x plus 1 will go, remain with the a times x squared plus 5. So you're going to remain with a times x squared plus 5. Then plus, you also multiply this and this. You're going to find that the x squared plus 5 and the x squared plus 5 will go, you remain with x plus 1 times bx plus c. So you're going to remain with bx plus c, bx plus c times the x plus 1, like that. So whenever you are using the repeated, the quadratic factor, always if you want to get easily the values of a, b, and c, just use the method of undetermined coefficients, where you need first to expand. You expand this, and then you also expand these two. After expanding, then you equate them to what is this side here. Then you'll be able to get the values of a, b, and c easily. So by doing so, we are going to say we have the 7x minus 4 is equal to, multiply the a with there, we're going to have ax squared, a times 5 is plus 5a. Then plus, we also multiply this with that, and then also we go this and that, this and that, and then this and that. We are just multiplying. So bx times x is going to give us bx squared, bx times 1 is plus bx, then c times x is plus cx, and then c times 1 is plus c. So after I've done that, you now need to make sure that you get the values of a, b, and c. So how do you get the values of a, b, and c? So to get the values of a, b, and c, you just need to equate. So you are equating using what we call as the method of undetermined coefficient. So you say by the method of undetermined and determined. Okay, so this is like this, determined and determined coefficient, comma, you are now equating. So you pick these that are having my x's, you equate them together. So you have 7x is equal to, here we have x, yes, bx plus c, so is equal to bx plus c, cx, which is equation 1. So I have gotten this equal to this plus that. Okay, then also we get these that have the x squareds. So we also have the do we have something which is having x squared here? No. So meaning that we are just going to say 0 is equal to a x squared plus bx squared. So we are getting this one, and this side is a 0 for x squared. So we put that as equation 2. Okay, so that is our equation 2. Then again, we need to pick those that are having so we need to pick those that are only having a constant. So we have a constant here, this 4 here, a constant. We also have a constant 5a and a constant c. So we are going to say that is negative 4 is equal to 5a plus c, 5a here plus c, like that. So we have these three equations. So this is equation 3. And then from there, that's when you can be able to get the value of a, b, and c. So by doing so, we are going to cancel. So the equations can be written as, remember, if you are to divide throughout here, by x, like this, meaning that equation will remain as b plus c is equal to 7. And then here, if you are to divide out through by x squared, you are going to remain with what? You are going to remain with a plus b is equal to 0. Then the last one will remain the same, which is 5a plus c is equal to negative 4. So these are the equations that we have. So we can solve these equations algebraically, and we'll be able to get the values of a, b, and c. So I can start by getting equation 2. So equation 1, equation 2, equation 3. So if I get equation 2, I have a plus b is equal to negative is equal to 0. So if I'm to make a the subject of the formula, we are going to have a is equal to negative b. So if a is equal to negative b, then we go on the other equation, the third equation, where there is a, we put negative b. So we put on equation 2, considering equation 2, so we say consider equation equation 2, meaning that equation 2 is 5a plus c is equal to negative 4. So that means whenever there is a, now we put negative b. So we say 5 times a, which is negative b, plus c is equal to negative 4. So this is 5 times negative b is negative 5b plus c is equal to negative 4. So we can call this as equation 4. So if this is our equation 4, then we now need to solve it. We can get this equation which is having bc, we can get this equation which is having b and c, and the first equation also which is having b and c. We solve them simultaneously and get the value of b and c. So the first equation here is b plus c is equal to 7, so we get it, which is going to be b plus c is equal to 7. The other equation for b and c is the last one that we've gotten here, which is negative 5b. Negative 5b plus c is equal to negative 4. So we can use the elimination method, minus here. b minus negative 5b is going to be 6b. Then this minus that is 0 is equal to 7 minus negative 4. We are going to get a negative 12. Okay, so we get negative 12. Is it 7 minus negative 4? This is going to give us a positive 12. So it's going to give us a positive 12. Then for you to get the value of b, say over 6, and therefore your b is going to be 2 there. Then to get the value of c, you can get an equation. So to get the value of c, you can get an equation which is, maybe you can pick equation, if you want, you can even pick equation, which equation can we pick? Let's pick equation 1, which is b plus c is equal to 7. So we have b plus c is equal to 7, and then where there is b we put a 2, so we have 2 plus c is equal to 7. Then make c the subject, you shall have c is equal to 7 minus 2. Then we shall say c is equal to 7 minus 2, which is the same as c is equal to 7 minus 2 is going to give us a positive 5. So we know the value of b, we also know the value of c. Now we need to get the value of a. Now remember, we were told that a is equal to what? Negative b. So for you to get a, just say negative of b. So you say, therefore, our a also is equal to negative b, which is our a is equal to negative, and b is 2. So a is equal to negative 2. So we know the values. Now after getting the values of a, b, and c, you now go and replace them here, so that you have your final answer for the decomposition of partial fractions. So you have okay, so we have what? We have 7x minus 4 over x plus 1. So 7x minus 4 over x plus 1, and x, the other one was what? The other one is x squared plus 5. So x squared plus 5. We say that this is equal to, we said a over x plus 1 plus bx plus c over x squared plus 5. So we need to replace the values now. So the values will be the value of a, we've got a negative 2, so we put negative 2 over x plus 1. Then plus b, we are putting a 2. So we put a 2 here, x plus c is 5. So 5 over x squared plus 5. So meaning that we've decomposed or resolved this into partial fractions. So we've resolved this, not that, this one here, resolved this into partial fraction. So this is how you decompose these quadratic factors into partial fraction. All right. The last one that we are going to do is decomposing. We are going to do what we call as decomposing improper fraction into partial fraction. So decomposing improper fraction into partial fraction. So decomposing improper fraction, improper fractions, or let's just say improper fractions. So let me just say improper fractions. So improper fractions. Now here what we're supposed to know is that we have what we call as improper fractions. Improper fractions are type of fractions where a small number is carrying a bigger number. Let's say we have 5 over 2. So this type of fraction is called an improper fraction. It is called an improper fraction because, why is it an improper fraction? It is an improper fraction because you have a smaller number carrying a bigger number. So it must interest you to note that the number which is on top is called the dividend. So the number on top is called the dividend. Let me write it here. So if you have 5 over 2, the 5 is called the dividend. And then the 2 is called the divisor. The answer that you get, so if you say 2 into 5, you get a 2, remainder 1 over 2. Okay, so this 2, the answer that we are getting is called the quotient. So this answer here is the quotient. Then the 1 on top is the remainder. Like that. Okay, now here we are going to be decomposing improper fractions into partial fractions. Now, how do you decompose improper fractions into partial, or how do you know that this is an improper fraction? So examples of improper fractions are, number 1, you are going to have maybe this 2x power 3 plus 2x or 3x plus 8 over x squared plus 3x plus 2. So you've seen the power on the numerator of x is 3, and the power of the denominator, the highest power of the numerator is 3 and the denominator is 2. That means that this is an improper, because the highest power there is 3, here the highest power is 2. So this type of fraction is called an improper fraction, and we now need to see how to decompose these type of fractions into partial fractions. All right, so now how do we do that? So to do that, so an example is, okay, let me just trace another example. So we have number 1, number 2. We can have also x squared plus 8x plus 13 over x squared plus 5x minus 6. Now in this case, if you see that if you see that what is up and down, you've seen here the powers are the same. So if the powers are the same, or the power on top is bigger than the one down, these are still called improper fractions. So if the powers down and up, the highest powers are the same, or the one on top and the one down, the one on top is bigger than the one down, then this is also an improper, this is also an improper. That's how you know that these that I'm dealing with are improper fractions. All right, so if that is the case, then what you're supposed to do is, now let's see how to decompose them into partial fractions. So example, we are going to say, so example here, we are going to say decompose, so we are going to decompose the following into partial fraction. Decompose the following into partial fractions. So decompose the following into partial fractions. Now we are going to have the first one, which is there, so we are going to do the same. So I'll just do this one here, and then this one you do it as your task. All right, so I'm going to have the 2x, I'm going to have 2x to the power 3 plus 3x plus 8 over x squared plus 3x plus 2. So we want to decompose this into partial. So now whenever you're decomposing into partial and you see that it is an improper fraction, what we need to start by doing is to reduce that improper, or to make it in a normal format. How do we make it in a normal format? You are going to use long division to reduce this into that. So you get, remember we're saying that this is our what? This is our dividend, and then this is our divisor. Okay, so we get the dividend, we put it inside the square here, which is the 2x power 3. Okay, let me write it a bit down. Let me write it a bit down. So we are going to do this. Here we have 2x power 3 plus 3x plus 8. Then in this side, we are going to put x squared plus 3x plus 2. Then after we've done that, what we're supposed to do then is to divide this into that. So these are partial fractions. So you just need to get the first number, you enter it into that. So when you say x squared into 2x to the power 3, we are going to get 2x you're going to get 2x power 1, because here we have 3 x's, they have 2 x's, meaning that the 2 and the 2 x's will cancel, remain with 1 x. Then now you start by multiplying also this to that, this to that, this to that, for you to get the numbers which are down here. So by doing that, you're going to have 2x times x squared, you're going to get a 2x power, so you're going to get a 2x power 3, and then 2x times 3x, you're going to get a plus 6x squared. I have just okay, let me just check if I've written there. Okay, so I'm saying that we have this. Okay, all right. So now whenever you see that, so I want to make a certain point here. I want to make a point that you need to understand. So I want to remove it again and start again. So whenever you see that the polynomial which is given on top has a missing power, so in this case we are supposed to have a power here, because it can't just jump from 3 to 1 power. We should have a power of 2 here, so which is not there, so it is missing. So what do you do if the power is missing? You need to put it. So by putting it, you are going to create it as a 2x power 3 plus, you put it as 0x squared, because the power of x is, squared is missing, so we put it as 0x squared, and then plus 3x plus 8. Okay, that's when I will say this into that. So this into that, you are going to have 2x. So you're going to have 2x, so I'm going to write 2x here. And then you multiply the 2x times everything which is here. So I'm going to multiply this to that, and that to that. So by multiplying that, you are going to say that you have 2x times x squared, you're going to get a 2x to the power 3. Then 2x times 3x, we are going to get plus 6x squared. And then you get 2x times 3, times 2, you get a plus 4x, like that. Then from there you subtract. So subtracting this minus that, minus that, minus that. Okay, so by doing so, we shall have 2x, this will go to 0. 0 minus 6x squared, we are going to get a negative 6x squared. And then 3x minus 4x, you are going to get minus x. Then now after that again, you say this, you enter it into that. So when you enter this into this, you are going to get a negative 6 only. So you're going to have minus 6. And then where do you write it? Or on top there. So we're going to have minus 6. And then that minus 6 multiplied throughout, you need to multiply it throughout there. Okay, so you need to multiply it throughout. Now, before, what you need to do there is that I said that after you've gotten this answer here, you've seen this answer, yes, we get this, we enter it into that. But there's one point that you need to do before entering this into this. So what you're supposed to do here is that, remember there is this 8 which is remained there. So what do we do? First drop the 8. So you need to drop that 8, drop it here. So it's going to be what here? Plus 8. That's when now you say this into that. That's when now you say this into this. You've gotten the negative 6. Then the negative 6 times now what is here, like this. So we do that. So by doing so, we are going to have negative 6 times x squared, you get negative 6x squared. Negative 6 times 3x, you get minus 18x. And then negative 6 times negative 2, we get minus 12. Then we subtract. This will go to 0. We put a minus here. Negative x minus negative 18. Negative x minus negative 18. We get negative x plus 18x, which is going to be a 17x. So we get a 17x here. Then 8 minus negative 12. 8 minus negative 12, which is 8 plus 12, which is a 20. So plus 20 there. All right, so that's what we have. Now, after I've obtained that, what you simply need to do is now to, here you can now, that's where you're going to end, because you cannot enter this into that, because this power now is bigger than what you obtained there. So that means if you just see that the power is now less than what is there, then you cannot now enter this into that. So meaning that what you've gotten here is your remainder, this is your quotient, like that. So how do you now rewrite your answer after getting the quotient, the remainder, and the divisor? So you say the answer is going to be the quotient, which is the answer. So you write like this, you say my answer is going to be the quotient, which is 2x minus 6 plus the remainder is 17x plus 20 over the divisor, which was x squared plus 3x plus 2. So that means that now we've reduced the improper fraction to proper fraction. You've seen now we have a proper fraction here, where the smaller power is on top and the bigger power is down. So meaning that we've reduced this to a normal fraction, which is a proper fraction. After that, now that's when you can decompose into partial. So which one do you decompose? You only decompose this part, this one you keep it the way it is. The quotient that you've got and keep it the way it is, and only decompose this what is here. So let's after decomposing this, the answer that we are going to get for decomposition of this is what we are going to add to this. Okay, so let's decompose this. So decomposing that is, we are going to say we have a 17x plus 20 over x squared plus 3. Okay, let me start it from here. So we have 17x plus 20 over x squared plus 3x plus 2. This is equal to a over, remember, rewriting this, let me just remove it. Rewriting this can be written as 17x plus 20 over x squared plus 3x plus 2 can be written as x plus 1 and x plus 2 if you are to factorize it. So you're going to have that. So this will be equal to a over the first factor, x plus 1, plus b over the second factor, which is x minus 2. And then from here you decompose. So you're going to multiply throughout by the x plus 1 and the x plus 2. Then if you have to multiply this into that, it will go, you remain with this, which is going to be a 17x plus 20 is equal to multiply this times that. You are going to have a open x plus 2, then plus you also multiply this to that. You are going to remain with a b times x plus 1. Then that's when now you can get the values of a and b. So if you want to get the value of b, let b to be -1 so that it goes to 0. So you let x to be equal to -1. If you let x to be -1 here, meaning that the part for b will go to 0, you minus the part for a. So by doing so, you have 17x plus 20 is equal to a open x plus 2 plus b open x plus 1. So let's now replace. We are replacing whenever there is x, we are putting -1. So we have 17 times -1 plus 20 is equal to a open x, we are putting -1 plus 2 plus b, we are putting -1 plus 1. Okay, so by doing so, we have 17 times -1 is -17 plus 20 is a 3 is equal to, here you have -1 plus 2 is -1. It's a 1 times a is a. This part will go to 0, meaning that our a is 3. Then let's get the value of b. So to get the value of b, we need to make sure that we cancel the part for a by letting it to be -2 so that it goes to 0, you remain with this part. So by doing so, we are going to say let x to be equal to -2, meaning that we are getting our equation, which is 17x plus 20 is equal to a open x plus 2 plus b x plus 1. Then here what we're going to do is we are replacing whenever there is x, we are putting -2. So we have 17 times -2 plus 20 is equal to a open, where there is x, we are putting -2 plus 2 plus b, we are putting -2 plus 1. Then this is 17 times -2 is -14 plus 20, we are going to get a 6, okay, which is going to be equal to -2, this part will go to 0, -2 plus 1 is -1 times b is -b, meaning that we divide by a negative, and our b is going to be -6. So now we know the value of a and we know the value of b. What do? We come here, replace now. So replacing, you are going to find that you put here as a and there also you put b. So you say this is equal to, we are going to say we have a over a over x plus 1, so it was a over x plus 1 plus b over x plus 2. But remember, we said that the answer that you get for this should be combined with which one did we left? Which one did we leave? We left this one here. So we left that. So that one that we left there is 2x minus 6. So the 2x minus 6, we put it here as the 2x minus 6 like that. And then I will replace the values of a and b. That's how we decompose improper partial fractions. So we're going to have 2x minus 6 plus our a. We found that it is a 3. So we put a 3 over x plus 1 plus b is negative 6 over x plus 2. So that means that this becomes our final answer if we are to decompose this type of partial fraction, which is an improper partial fraction. So from there, I want you to try out this one and see how it is going to come out. Alright, thank you so much for watching my videos. This is the Radical Tutor. Kindly don't forget to subscribe to my YouTube channel so that whenever I post videos, you'll be able to be notified that I've posted some videos. See you next time. Bye bye.